Howdy and welcome back. So clause 2 and this thing called a dangling pointer. What is that? Well, we'll get into it. So the second clause was that you will immediately stop using the memory that you've returned. And the violation of not doing this is going to be a dangling pointer. Essentially, a dangling pointer is going to be a pointer to a piece of memory that has been deallocated. So one thing to keep in mind is that until that memory is allocated again, you may continue to get the value that was stored in the object that used to reside there. So let's go ahead and say set up this. So we all say P is a pointer to an integer object dynamically allocated on the free store that's initialized with 7. So we have this set up right here. And then let's say we do something and we're ready to return P, or the object pointed to by P. So we call delete on the address stored in P. And at this point, all we've done is deallocated the memory associated with this object right here. Notice at this point, we didn't update the value stored in our pointer P, meaning pointer P still stores the address that was returned by the new operator here. So it's still pointing to that object out there in memory. However, that object's memory is no longer allocated for it. What does that mean? Well, C++ isn't going to zero out the memory when you're done with it. It's just that's inefficient. Instead, it would leave the integer value of 7 within that memory space. And through this dangling pointer, so after this line, you might be able to write something like dereference P, and you might get back 7. And you could even go to that address and assign it a new value. The problem is that that object space has been essentially noted by the free store manager is now free and can be used for something else. Therefore, while we might be able to continue to see this value that used to reside at that location, the second the free store manager determines that a request is made and hey, that memory is conveniently available now, it might fit in what the person's requesting, it could go ahead and assign that memory location for use in maybe another integer object or some other type of object. Well, at that point, when you go into P to check out what's there and you're expecting this integer value of 7 or whatever you were storing there, something very different will be there now, and it won't be what you're expecting. So this is a trivial example where you're going, well, if I call delete, I can break this connection on this line by just saying P is equal to null pointer. The problem becomes that in our programs, we might have multiple pointers to one dynamically allocated object, and you might return that memory in one place, and you might even null out what that pointer pointed to. But in the other case, you might still have this relationship to the previously allocated object. And this becomes to resolve this, it becomes, you're going to have to do some accounting on your part to ensure that the objects you're pointing to have their memory allocated for and are not dangling pointers. So to show, I don't know, maybe a bit more of an example that might reflect better what you could encounter is, let's set this up. P is a pointer to an integer object dynamically allocated on the free store. It's initialized with 7. Somewhere in your program, you create a pointer to that object. So you say OP is a pointer to an integer object, and it's initialized with the address of that stored in P. So at this point, both P and OP point to the same object, which means that we can interact with this object right here indirectly through either P or OP. Now let's say somewhere else in our program now we've decided to give that object back to the free store manager. We no longer need it. So following kind of best practices, we deallocate the memory to return it. Boom. Free store manager can now reclaim that for use in some other object. And then we null out the pointer. So we break the relationship. Okay, that's all good. So now we're here. However, notice that OP is a dangling pointer. It still houses the address of that object that we used to have memory allocated for, which no longer does. which means back to this example, through OP, we might continue to access this region in memory, that region that used to hold 7, and we might observe 7. However, when that space is finally reclaimed for use with something else, when we go into that memory, we're going to observe something very different from what we expected. So to kind of, I don't know, walk through this, an example I used to always give was a storage unit kind of example. So I guess I'll just keep it on this slide. So let's say you, I don't know, you need to store some of your stuff somewhere. So you go to an establishment that rents storage units. So the first thing you're going to do is you'll probably go in and go, hey, I need a storage unit. They might ask, okay, what size? And you might say big enough to store an integer value. You know, obviously this is kind of silly at this point, but okay. So they tell you, you have unit number 8. So you write unit number 8 down on your note card and you walk to that storage unit, you put your stuff in there. Let's say you don't bother taking your stuff out when you're done. You simply return your note card to the storage unit manager, or let's say you simply go back to the storage unit manager and say, I no longer need unit 8, but you keep that unit written on your note card. And then let's say you, despite being against the rules, you continue to go back to your storage unit and keep putting stuff into it, though it's not yours anymore. Each time you go back, you can see your stuff. It's still there. And you're like, wow, this is awesome. I'm getting free space. However, eventually that manager will re-rent your storage unit to someone else. And you might go back and your stuff is no longer there. So that's kind of the idea with this dangling pointer is you're continuing to reference something that is no longer yours. And you might continue to see your own stuff because you were too lazy to zero it out. The manager was too lazy to zero it out. So it's up to the next person to essentially replace your stuff with their own stuff. So one day after you've returned it, you go out to the unit and you look in and someone else's stuff is there. Might catch you by surprise. But yeah, that's what happens when you're interacting with a dangling pointer. When you likely will see what you're expecting. And then at some point randomly, it won't be there anymore. And these bugs are very hard to track down. So with that in mind, let's go ahead and move into clause 3 and runtime errors.